Спасибо. Привет. Меня зовут Себастьян. Я работаю в качестве евангелиста программного обеспечения для IBM. Я учу русский, но я еще плохо говорю, so I think it's easier if I talk in English. And yeah, hi and welcome to this talk on making enterprise testing, enterprise applications, and especially Java applications more joyful, more fun. Yes. So I have a question. Who of you likes to test? Hands up. Okay, so I'm at the wrong conference. Usually nobody likes to test, so you're already there, you're done. Okay, and just for me to get a better experience, who would describe themselves as tester or as QA? Hands up. Okay, and who would describe themselves more on the developer side, like more writing code side? Okay, that's good. So some mixture, that's great. So about myself, my name is Sebastian, born and raised in Germany, and I work for this company called IBM, and I'm typically on the Java side and on the enterprise development side. So I'm a developer mostly at heart. I have experience in supporting many enterprise projects, and therefore I've seen many things that enterprise projects would need, and testing is definitely one of it. So almost all the projects lack some proper testing, especially some proper automated end-to-end testing. And typically I talk to mostly developers, but also all kinds of engineers, I would say. And especially this conference is very interesting for me to talk to many, engineers with a testing background or with a QA background. So I hope there's something interesting for you there as well. I will have most of the content with a developer's perspective in mind, but ultimately when we think of the DevOps movement or that a team should deliver working software movement, that the team should work together, I think it makes a lot of sense if, both backgrounds or if different type of backgrounds of people get a common perspective and talk to each other. So about that. Another fun fact about myself, я люблю кофе. So this is why I have actually coffee example, what I will show you. So a lot of examples or things that I see out there or conference talks, when it comes to testing, then from my experience, a lot of these examples are somewhat too simple, right? Like hello world examples, and it's very easy to, test something like an HTTP REST endpoint that just says hello world. Yeah, that's a little bit too easy because you only see the real issues, the real problems when you go to a more complex project, right? When you have more complex use cases, when you have a lot of functionality that changes, when you're dealing with test data, when you're dealing with external systems, right? Then testing becomes a little bit harder. So I have some example that at least shows, I would say is complex enough that has a few things that makes it more interesting. So we have a coffee shop that a user would use to order some coffee, and then at least that coffee shop, that will be a Java application, and that has some persistence, so a database, relational database that it talks to, and then also we have an external system, a barista, the friendly barista person that brews you coffee, and this communication will be done asynchronously, which also makes it a little bit more interesting to test for us to verify whether all of the communication within our coffee system works. So that is pretty much the idea. We have a coffee shop where we order some coffee. For us, we use HTTP as an example communication. So we order some coffee using HTTP and JSON, and then this will be persisted, and at some point, this coffee order will process to the barista, and then our coffee will be brewed, so the status will be updated. All right. I'm not a big fan of slides, so I will mostly show you live code and live demos. So this is now related a little bit to Java. That is basically the project that I use. I built this, what is called Coffee Shop. And also this is our application that we want to test. So that is the project under test that we want to verify whether it works correctly. So we want to see whether this coffee shop project works as expected. And then let me build and run this whole thing. So as developers or as engineers, we have many ways to verify something, different scopes, different platforms where we can run stuff. But let me just start from a developer perspective, where I want to verify first of all whether my application works on a local basis. So very simple, the easiest step. Last night we have a very interesting BOF session on the question: should developers test? I would say the answer is yes. Yeah, and of course the question is on which environments. So first of all, what I will use is I run my application locally as an engineer, and I use Docker containers to do so. Who of you has used or heard of Docker containers? Okay, a lot. So that is a very nice abstraction to run stuff locally without, needing to manage too many things yourself. So I run now 3 Docker containers. Why 3? Well, because one for the coffee shop, one for the barista system, and one for the database. All of that can be run locally as Docker containers. And I do this here. So I have my coffee shop, I have Postgres for my database, and this barista service. And then once that is up and running, I can actually go and talk to my application, for example, using the browser or any, I can use Postman, I can use even some testing tool that supports HTTP, or I'm a command line person, I just use the command line. And then I have something like coffee shop, resources, that is the path, like the path base URL to my application, and then I already get some nice response with some hypermedia links that tell me, okay, I can order some coffee by HTTP posting to this URL and so on and so forth. Okay, so then we see we have a URL that is called orders, where I now get my coffee orders. So that is now the main operation that we want to focus on. We want to order some coffee. Are you interested in the Java code? I can quickly show that to you if you're interested. So this is now a little bit more specific to the enterprise Java example that I have. So if you're familiar with that world, either with enterprise Java or with Spring, this looks very similar. I have something like an HTTP resource here, right, /orders. That implements the endpoint on the development side here. And I can, post some coffee or get some coffee here. I can create a coffee order, and then this will use my business component to basically, store it in a database. So there's not too much going on here. This is using some ORM Java mapping to persist it in my database, and pretty much that's it. Okay, in order to do that, let me create some coffee now, finally. How do I create some coffee? Now, this gets a little bit more interesting. That's the part of our contract, how our application works. In my case, I want to say, okay, I need to, just briefly saw it, I need to post something to that resource /orders, and I need to post some JSON, that has my, information for the coffee order. So, of course, that should be, like documented properly. That is the Java object that will be mapped via JSON. So I have coffee type, I have a origin. So what does it mean? A coffee type is basically the drink that you want to order, something like, an espresso or, a latte, right? And the origin is, where the coffee beans come from, right? So in a nicer coffee shop, you sometimes can select, do you want some coffee from Ethiopia or from some other exotic country? So let me post something to this resource to basically create this, right? So we want to say something like type espresso, origin, let's say Colombia. Oops, yeah, I should properly, it was too fast. Should properly create the JSON, and then good news, 201 created. My coffee has been created, right? And now if I'm lucky, I see this coffee here as well. Okay, good news. The coffee is in the system. Now the orders resource gets me not only an empty JSON array, but actually the order, and it already has a status collected. So that's interesting. If I look at the statuses, first of all, it will be, preparing, then it will be status finished, and then afterwards it will be status collected. So this is because of the asynchronous communication to the barista backend. Once the order is in the system, then at some point my systems will communicate with each other. Okay, now it works, right? It looks good, right? Ready for production. Yes, it works locally, right? It works on my machine. That's already a good statement from developers. Well, as testers, this doesn't say much. But now the point is, how do we test this a little bit more properly? If you're a tester, from a tester perspective, I used curl, right, to test it, but that is pretty much one use case that you could verify on a tester perspective, on an end-to-end perspective. You go and connect to the system using curl, using Postman, using whatever tool you want, and then you perform some actions and verify, okay, does it work? Is the order in the system using espresso and all these correct information? Okay, now from a developer's perspective. And the question to the answer, should developers test? Yes, they should, I believe, is if I would like to write a test, if I would like to implement some automation to verify what I just did on a command line, well, how would we do that? If you take a developer with, or can also be a tester, an engineer with Java knowledge, and let them implement, a Java test, then you probably end up with something like this. Let me write just a Java end-to-end test. A Java class, it really doesn't matter whether this is Java. This is now my system test project, can be totally isolated, can be, like from a tester's perspective, I have no clue how the coffee shop is implemented. I just happen to be a Java developer. That's why I use Java to implement my test as well, right? So that's fair enough. I use JUnit here, but really doesn't matter. And now, from an abstract perspective, from a pseudocode, how would I test this? Or how do I see this typically in projects when a developer or an engineer, a programmer, would implement the system test? Well, what did I do in the command line? I did something like, in order to create a coffee order with espresso from Colombia, I have to do something like HTTP post, right? HTTP post to something like orders. And then what do you post to? Well, we had this JSON, right, with, I had type espresso and then origin Colombia, something like this, right? Now, if I can type, now you have many, many ways to basically describe this. It can be, pseudocode, it can be some programming language, it might be any tool, right? But that is basically what you do. And then you can say, okay, now also verify that it's HTTP 201 created, right? Something like this. So verify the status code that, it works. So once this is the case and you perform this action against the system, then you already know a lot. That's already good. You know that it works. This order accepts your JSON, and it also said 201 created, so it's pretty much good news that this is the case. But then you don't trust it. You also say, please connect to the system again, what I did basically using this action, or I can also use this action to connect against this URL and to see, okay, now check whether the information is also correct, right? Because it might store it incompletely in my database or something like that. Okay. Let's do this. Then, I have to send another HTTP GET request to, well, which URL? If you paid attention, you saw we had the HTTP location header with the HTTP communication. And then we can say something like, save order ID from, this information. That's just pseudocode, doesn't matter, right? But I basically want to specify, now I will use this identifier, this URI, to get my information. And then, verify, once you read the JSON, verify whether, the order basically is espresso or has espresso from Colombia, right? That is basically what you would test. Well, what else can we verify? We also should verify 200 OK. That can also be implicit if we read the JSON. But that is basically, how we would write a very naive system test. Who has seen tests like this in projects? If you look at some, code that people implement. Yes, I've seen it a lot. So who thinks this is a good idea to write or implement your test using either, okay, one honest person, using either Java or any other programming language, but using an approach like this? Well, I don't think that's a good approach. Why? If we think of code quality and basically the abstraction, what we implement here, this method does too much. Or in other words, this method has too many responsibilities. Why? If we say it differently, for example, what happens if we call this test create order with espresso, and now tomorrow we have a new functionality, we also support cappuccino. So what you do, or what would an engineer do to also, now I implement the cappuccino on, I'm a developer, I implement this. Now I also want to verify whether it works. Well, what do I do? Of course, copy-paste programming. Yeah, of course, that's what I do, right? Cappuccino. And then I have a close look at my code. Okay, the cappuccino here. And, oh, cappuccino down there. And I'm done. Works, hopefully, right? Okay, perfect, good. Whew, solved. Testing still 100%. Okay, now next week we have also not only Colombia, but Ethiopia. And then like, oh, darn, okay. Now go here and, take the whole code and take both espresso and, you know where this ends. So that's probably not the best idea. And that is even easy to manage if I can just copy paste. But now imagine I have like 10 of these methods, and that is only the short version because it's pseudocode. If you would implement it, then it would be like, I don't know, 20 lines of code or more. Now imagine what happens if HTTP changes to some other protocol, or JSON changes to XML or to, protobuf. Well, then you're screwed. You can throw away the whole thing, right? And you can rewrite it from scratch. And also what is really hard to see is, and this is now what the testers are more used to, that perspective, is the actual test scenario. The question, what are we going to test? So originally I wanted to test to create an espresso from Colombia, to create my coffee order, but you don't even see it because this information, create order with espresso from Colombia, it's hidden and buried in many, many lines of code. So you don't even see the whole thing. You cannot really read it. It's not comprehensible as a human. So let's delete this and try it again. Create order. Now, and this is probably what, at least from my experience, testers or engineers with a QA background are much better at. Let me start from a perspective, and this helps developers a lot, where you first of all think what you want to test. Thinking is always a good idea. And you start from a very high level perspective. So this is why I purposely write in comments, and I do this in projects as well, or sometimes even on paper, where I say, okay, let me now think of it what I want to test first. So what I want to do, I want to create coffee order, with espresso from Colombia, right? That's what I want to test on a very high level perspective. As a user, as a tester, I don't care about HTTP, I don't care about JSON. I want to create a coffee with espresso from Colombia. And then, of course, I want to verify whether that coffee is in the system correctly, right? So I want to say something like this, verify, you can still say, save order ID just for the identification. Verify whether order ID with that identifier is basically, well, has espresso from Colombia or something like this, right? And then again, you don't care how it is implemented. So from that mindset, and that is pretty much what testers, the test scenarios that testers create. So what should we verify here? Then you implement that only on a second level. And then as a developer or as an engineer who implements these tests, what helps a lot is then to, well, basically create proper abstraction layers. So I have implemented this now slightly differently. In another test where I now basically use delegation to solve how do we implement this creation order. Actually, if you think about it, if you have a programming background, this is what we always should do for proper code quality in production code, right? To use delegation, to craft proper abstraction layers. But for some reason, we care a lot about that for production code, but for test code, developers usually don't care, right? Because it's only test code. We can do whatever we want. Wild West, right? We can copy, paste, and whatever. Nobody cares. But well, we do care because it makes a lot of effort, it makes a lot of difference, which we will see in a second. So what I do here, I create two delegates, one coffee order system. And now let's have a look at this method, create verify order. This is now the Java implementation of what I just did in pseudocode. What do? Create new order, espresso Colombia. Okay. And then coffee order system, create order. Okay. That is pretty much what I just wrote in Java. How is it created? I don't care. I don't want to know. That is not part of the test scenario. Just create order, espresso Colombia. Then afterwards, coffee order system now get me the order with this identifier that you just got back, and now verify, this is as for J, whatever, verify whether these fields, whether this information type and origin matches espresso in Colombia from what we had before. And then also assert that the list of all orders contain my order that I just created. So basically that it's there, using this information. That is what I implement here. That is now, I claim, much more readable. And with that, we immediately comprehend what it is about, right? Create order, espresso from Colombia. Then get the order and verify whether it's in a system. So that is pretty much expressive of what we want to test. Now, if I have to change something here, or if I have to look how do we implement it, I can have a look at the coffee order system, which is basically a sophisticated HTTP client with a nicer API. So I say, okay, please go to whatever, localhost, and see, this URL, we know this already, and then implement how do you get the orders. Well, we make an HTTP request and map some JSON and blah, 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 blah. Don't care. Or how do we create an order? Well, we send a request that has been created from JSON and a lot of low-level details, but we do not leak these details to our test scenario. And that is now the important part, because first of all, if we create a new test to not only verify espresso but cappuccino or something else, well, then it's easy to do because it's easy readable. It's just a few lines of code. We can create a new test. And more important, what if behavior changes? What if HTTP changes to something else? What if we change the status codes, the JSON mapping? Well, here we don't care. We don't have to adapt, and this is only one test, right? But if we have hundreds of test cases, we don't have to adapt them. We just change the driver, the dependency that we have here, the delegate, which is this class. And it's only one class that is being reused by having reusable component. Again, if you're a developer, then this should not be anything new, right? Because on production code, we tend to do this, all the time to create proper delegation, to create reusable stuff. But even developers, when they write test code, for some reason, they don't care. And it makes a lot of sense to, care about these things if you implement a test. So that is from a system test perspective. And the most important principle is this. Abstraction. Actually, if you think about it, abstraction is, I believe, the most important principle in IT in general. That is the reason why all of us can even use a computer, because these devices are extremely complex, right? I've studied computer science, but I have no clue how, the mechanics of a computer work. I mean, I learned it at some point, but how the electrons go through these transistors and through which gates they go through, AND gates and OR gates, and how all of that works. Who knows that, right? I don't. Yeah, pretty good. But all of that works because of abstraction. As a programmer, as a tester, as an IT person, you don't have to know, because you build upon many abstraction layers that hide all of that complexity. And here it's somewhat similar. It's, again, just the same principle applied. And only then you are able to create maintainable tests, and tests that are easy, easy to change, and tests that are easy to read and easy to comprehend. So that makes all the difference here. A little bit more on the system test perspective. So what I now did, I created a test to verify, this creation. But that is also a little bit boring still. What I now want to show, what to do if we want to test this communication between the coffee shop and the barista, right? That was the second step, right? If you remember, I created a coffee, and then at some point it had a status as well, and then the status changed because of the communication that happens between these two systems. And now I want to create an end-to-end test that verifies this as well. And on this level, on this scope, I just want to verify my coffee shop application. I don't care about the barista backend in this scope. There might be other scopes where I have a more inclusive end-to-end scope that tests everything. But on this level, I just say, I'm interested about the coffee shop, and the rest is what we typically do with code level tests is mocked, right? Is simulated away. I don't care, I just assume it works. So in this case, what we can do, we can mock the barista with, a mock server, something like wire mock, or, an HTTP mock server for HTTP, or anything else. You can write your own mock if you want. The database, it depends what is easier, whether to want to use a mock database or just the actual one and, assume it works. And from this perspective, then what we do, well, I create another system here, barista system, that now, in my case, communicates with WireMock. That is basically a technology where I have some mock server that I can control. So as part of my system test, and what I will do, I also talk to the barista and basically control and do the verification, right? So basically say, now I will expect some communication here, so please react in the following way, right? So basically you control that mocking or stopping behavior. And in order to do that, let me fire up another test example that looks very similar. So again, Docker containers help a lot here. System test. So basically what I can do, I can again run 3 Docker containers, but now I run it slightly differently, which I will explain in a second. And especially, I will run my, not a proper barista server, but my mock server. I will use wiremock, and then if that whole thing runs, you can see I have a coffee shop still, I have my database, and now instead of the barista, I have actually wiremock, a different Docker container. I swap this, where Docker containers make it really easy to do this. And then I can use, wiremock and control it to modify this behavior, which is really helpful here. And then once that is up and running, I can basically, again, ask for coffee orders here, which are empty. But now, instead of my of doing that on a command line, I now want to use the system test to also use the barista to control it. How do we do this? I have a second method. Create order check status update. Now, if you think of it, again, from a tester's perspective, how does my test scenario need to look like? Well, first of all, I can create a coffee order, and then, well, I assume this communication is about to happen. I actually don't know when, because it's asynchronous, if you remember. But at some point, I know that my coffee shop will call my barista system, and then I tell the barista system, okay, now please, in order to make this happen, answer for this coffee order with the following status. So if you will be called in the future for this order identification, then please respond with the status. The barista system is basically a status update system. So what I do, I create my coffee order again. I prepare the barista mock to respond in a certain way. And then I say, okay, now, first of all, check whether the information is correct in the system. It's the same story. And now, that is a little bit, the best thing we can do. I tell the barista system, now tell me when you have been invoked with this information. Why? Because we don't know when it's going to happen, because it's asynchronous. So the best thing, unfortunately, we can do is, well, to wait and poll for this update to happen, right? So how that is implemented, well, very basic. I basically have to, wait until a certain timeout, whether that particular request with the particular information has been sent. Other than that, what the barista system does here, it just, again, provides a nice abstraction over this, how do I answer for an order? Well, I basically configure my wiremock and so on and so forth. And this is then how I implement this test. It looks a little bit more complex, but if you think about it, it still implements exactly what I do on my test scenarios perspective. Say, create an order, now reconfigure this system to respond in this way, then reconfigure the system to respond in that way, and then wait for the ping-pong status update until it works. Okay. Enough talking, let's finally try this out. Create verify order, let's run this test. I run this again using Java, so I can run it in my IDE, I could run it from the command line or using Maven, what I used to build my project, whatever. Green, works, okay. So that test just worked, and I even can check it, I have an order in the system here, okay. But now the more interesting example is the test that does, this ping pong, by using the barista service as well. Now this test actually takes a little bit longer, but that is not the fault of the test itself, not the test technology. That is due to the test scenario, because this asynchronous communication will take a few seconds to happen, like always 2 seconds until it will be invoked again. And then now we see, okay, it's also green. And now we even have more systems, more coffee in the system. So that is basically how we can implement a system test that uses this, mocked behavior. And again, I'm running the whole thing locally. So if you're an engineer or a developer who wants to try out all of these things, and we should test it ourselves and should test it locally before even committing it and running it in the CI/CD pipeline, right? So we have the verification whether the whole thing works before we even, annoy our colleagues by a breaking build. So that is a very important thing as well, to get a faster feedback for us as a developer. So that is one thing to be said about end-to-end tests. Now, again, I mostly see this whole topic from a developer perspective, and I really want to emphasize that if you're an enterprise developer, then you need to have two things. First of all, the verification whether the whole thing works when you do something, when you have some code right before you commit it, and that includes end-to-end verification, at least end-to-end in a way that you call your application in the same way like a user would call the application in production, right? Like this HTTP and not just some mocked behavior on your coffee shop application. And the second thing is you need a fast turnaround. That is, together with the maintainability, the biggest part where developers say testing is not fun, right? Because testing typically takes a lot of time, right? If you run if you have a Java project and you run your Maven build, most developers would say the Maven build takes like longer than 1 minute, right? Or a few minutes to run the whole build without skipping the tests. And this is just way too long. Why? Because we are humans, and humans, in order to go into this flow experience, to have this nice experience that we program and we get immediate feedback whether our stuff works, we need to have this immediate feedback. And just waiting a few seconds is too slow, right? Because we're humans, we get distracted, and then, I have to wait for something. So, of course, I take my smartphone and check, like, Telegram and Slack and email and whatever, and I'm distracted. So what I want is a mode where I can just change some code and see immediately the update as an engineer. And this is now where especially engineers or developers and testers can work together really nicely if they can communicate, and if the developer also have these test scenarios or something similar to this available that they can run against their changes locally. For example, I now am running my application here as before, so you can see this, right? But also I'm running my application in a special mode that is using OpenLiberty, the enterprise runtime that I use here, which comes with a development mode that actually does some hot swap changes. So for example, I have this URL here, this root URL that I had before, but now also what I can do, actually this has the connection to my code repository here. So this is the code that produces this crazy complex JSON. And if I change something here, hello world, then thanks to this technology that is running, it's immediately being reflected in my changes that I have locally. It does not need to wait, seconds or minutes to restart. It's immediately being hot swapped on the running runtime. So if you're tested, then you might say, I don't care, developer stuff. Well, for a developer, this makes a huge difference, because now if you say, I change hello world to goodbye world or to something else, then immediately I can see the change, and I don't have to wait for an update, right? So talking about this feedback loop, I immediately get feedback. Or if you change, Privet, wait for it, Moskva, da? It's super hard to type on such a keyboard if you just learned that, because every letter is different. Yeah, you can have this change as well. So again, fast feedback. If you change something as a developer on this production-like running example, you immediately see the value. And much more important for you from a tester perspective, you also want to build up your tests in a way that you get immediate feedback. Here, this works really, really quickly, because this test technology, what it does, it just connects against something that is already running, right? So again, if I change some code, I see my changes immediately. I can change the test scenario or how the test is implemented and run it and see the changes also immediately. And I say this because of a lot of technology, especially in the Java world, does it quite the opposite. That means if you start a test, only then it starts your application, or it starts firing up some embedded scenario or whatever, and that just takes too long, because then you always have to wait 10 seconds or 20 seconds or more until you get the result, whether it's green or not. So that is very crucial to get this fast feedback. Now, something else on the code level perspective. So what I was talking now was system tests or end-to-end tests that test your application from a outside perspective. Also, I'm not sure how much you're into this world if you have a testing background, but what is also important for developers especially is to have this code level. test. So basically something like unit tests or more like integration code level tests that verify whether a single class or a collection of a code works together as expected without firing up the application. So it's a question of balance, how much it makes sense, because ultimately the more you have some communication and some collaboration in your applications, the more you need to verify whether the contracts are being met, right? By using HTTP, by using the database and all these actual functionality. But it also already gives a lot of benefit to test something just on a unit test level or on a code level, right? Especially if you have something like a highly sophisticated algorithm with many different branches and different decision paths. And then just for that high cohesive class component, like a Java class, it makes sense to write a lot of unit tests where you can just fire up the tests and run them very quickly and have even faster feedback whether it works before you even have to start your application, right? So this is a little bit more for folks with the developer background. If I have now some tests in the same project, in my coffee shop project, that test something on a code level, it might look a little bit like this. So I have something like a very basic unit test. In Java, I use typically JUnit with Mockito, SRJ, if you have heard these technologies, and then I just have my code, have my object that I fire up here. I can instantiate that, and then I can run something like test these business components, test these use cases, and just run these tests. So if you're a developer, that is super basic. It's basically how to write a unit test. But from a developer's perspective, this is already very important that you care. So I care a lot about that you run your test technology with a very basic way. So this is just a plain JUnit without any test runner, without any extension, without any black magic. And then the benefit you get, it runs really quickly. It runs fast. JUnit is a really fast testing technology. You can run hundreds of test cases within milliseconds. So that is really effective, and that enables you to write even complex test suites with just a few milliseconds or seconds of runtime if you do the whole project build. What is now a little bit more interesting, if you build up code level integration tests that want to integrate a few more components. So for example, you have a few Java classes or all the classes that are involved in one use case that you want to verify. And now assuming I want to verify that use case on a code level already, just to get faster feedback as an engineer. Now, how do I wire these up? That is actually not trivial because you have many code dependencies. So the coffee shop uses some other component, and this uses something else, and that uses something else, and so on and so forth. And if you've done that on Java, for example, it's a lot of effort to set this up manually. If, for example, you do some mocking or some instantiation of others, this is why integration test frameworks such as Spring context tests or Achillean on Enterprise Java or CDI unit, if you heard about these technologies, were quite popular. They basically, what they always do is to fire up a simulated environment, something similar to your runtime or to your server, where you can instantiate a few classes and then just test and inject these classes and write these tests a little bit faster without wiring up all of that yourself. But the biggest problem of these tests is they run slow. And slow, I mean not super slow. The test might run in 2, 3, 4, 5 seconds. But typically what I see in projects, then at some point you not have one test, but hundreds of these tests, and then they take 2 to 5 seconds each time. Typically, at least if you run them in the default mode, and then what happens, you end up with testing times, with test suites and run for minutes. And from a developer's perspective, that is way too slow, right? Because you're firing up your build, and then it just takes 3 minutes to run the whole Maven build for Java. And this, is not effective. This doesn't give you this fast feedback loop. So what I come up with, actually what I described in my book, for that reason was to come up with something that I call use case tests or component tests that are, a code level integration test that fire up all of the components that are involved in one use case, right? For example, the use case of creating a coffee order, now programmatically on the code level, and I want to verify this, how could this be done? And this is now the very naive way. This is why it's called naive use case test. Don't do this. This is like the bad example. It would be something like, okay, I need the coffee shop, right? This is one class that I need. But in order to use the coffee shop, I also need the entity manager and the order processor. And this one needs the barista service and so forth. And then at the end, you end up wiring up 20 components. And you see, I even have to use some reflective stuff and black magic. This is not readable, and this is not a nice way, right? The benefit is this runs fast because it only uses, code level without some extra magic, but it's not maintainable. And the worst thing of these of these code level tests is what happens if you change something, right? If you refactor your code structure in the production code, well, congratulations, then you just break all of your code level tests, right? Because you assume that, you have something like a mocking field here and that exactly is this class, it's called this way. If you change something here, that will not even compile anymore. You have to change all of your classes. And then what happens, what I see in projects, you have hundreds of these test classes, you do some refactorings, and then two things: either you don't do refactorings, which is bad, or all of these fail to compile, and then you delete all of your test classes, which is also bad, right? So what you should do instead is, again, care about the quality that you use here, the code quality, how to construct these tests. So obviously this is not the best idea, right? What you should do instead is, again, to have something like this. I use a use case test, let me call this again, and now I craft reusable components on the test scope that then already make sure that this wiring up and this, verification of all of the components works already. So for example, for the test, for the coffee shop, I create something like that is called test double that actually extends my class on the test scope that just already, again, use and implement these abstractions to create methods like verify the creation or verify this and that, or now answer to the, when of these unfinished orders, and so on and so forth. And then you have all this, low-level wiring up of Mockito and your mocks and stops and whatnot. But in your test, in your actual test class, sorry, that was the wrong one. In your test class, you just use this component and then, or these two components actually, and then what you can do, this is your test code. You can very clearly say, create coffee order, now verify. Done, right? Very similar to what you saw in this system test perspective. So again, what you do, you create proper abstraction layers and reusable components that you can use in, your many use case tests. So I can build up many of these tests that only, instantiated these two things. And then I can even have some more sophisticated examples, say now answer for this, now then process, then verify, and so on and so forth. And how it is implemented, let's look in the other class, that is done in this component. And now, if now something changes on the production side, then I have to modify just this reusable component and not my hundreds of test cases here. So on the ASCII art diagram, this looks something like this. My production code has, this is the example of my coffee shop and my order processor. And now on the test code, on the test scope, this is related to Java, but basically in my code level test suite, I create reusable test doubles, reusable components that then already make sure that this wiring up and mocking and stubbing and verification works, right? And these components then only being reused in my use case test, in my test that basically then are easy to maintain and easy to read. And that's one of the most important things here. So again, just the same principles applied here for test code. And of course, this, as I said, it only uses plain, Java testing technology, JUnit, Mockito. So these tests run very quickly. And these are just two, but if you add more, pretty much same execution time. You can run hundreds of these tests very quickly. So now if I change some code, only on a code level, as an engineer, as a developer, I can already run this test suite and, I have very quick verification, instant verification whether it works. And then as a next step, I do something like the end-to-end test, what I just showed you before. And then I have very quick verification whether the whole thing, works as expected. So that is basically one of the most important takeaways, this code quality and this abstraction. even if you are not on the development side, but more on the testing or QA side, actually it's the same story. It will just be a different language or different tool that you implement. You can use the same ideas to craft some proper abstraction to then implement your test scenarios, right? Or in the idea world, you work together, as always, nicely working together with the engineers who can then use your knowledge, if you're a tester, your test scenario knowledge to implement something like this, to make the whole world better by already having these test scenarios being part of that, suite that the developers also can use, right? Because then you will just reduce the time, time to feature, time to market. Because the developer can already use that knowledge of all of the testers by executing the same scenarios and by verifying, even while they're creating new features, by verifying whether the whole thing still works. So automation and using that appropriately. Okay, now some takeaways. So the most important thing is, as I said many times, that the test code quality, it matters. Doesn't matter whether it's in the same project like what the developers develop, like the test suite. Doesn't matter whether it's a special project like an end-to-end system test project, or any other testing suite that a QA department or that testers would use. It just makes the whole thing more readable and more understandable. For engineers, for developers, what is really important to have this fast feedback and especially fast turnaround cycles. So whatever technology you use, I can give you some pointers for enterprise Java, for this Open Liberty development mode, what I did. But in general, you just want the fast feedback while you are developing, while you are coding, right? That is both true for that you have some production thing running locally that you then can just quickly reload, or for your tests as well. So your tests need to run fast. And that typically means you have to separate the life cycle of your tests from your test environments. So especially in Java, I say this because from a Java background, people tend to build everything they just possibly can into their unit tests. And once you start the unit test, the test starts to build up the whole world, and start up multiple Docker containers and this and that, which is quite handy to create the tests. So it's easy for developers to create these things, but it's not really fast, because once you start such a thing, it just, you have to wait seconds and longer until the whole world is being created, and only then the actual test runs. But if you separate this, if you start the whole environment, in the morning, in the beginning of your coding session, and then you can just reuse the already running thing, and your test is very quick because it just connects against the running thing, then it makes it whole much faster. From a tester perspective, this mostly is even obvious because you're used to test against a system that is already being running, right? And then, of course, this is just much faster. But for developers, that's unfortunately not always obvious. Reusable idempotent test scenarios helps a lot as well. So, for example, if you create the test scenarios, then assume you are running against a system that will be running for longer. So not just firing up your system in a well-defined state and then testing, and then you need to roll back to this very state. So it makes it much easier to be idempotent, where you can run the same test again and again and again, what I showed you. And it also helps a lot in creating test scenarios that they can reuse against other environments. For example, let me show you another demo. Who of you uses Kubernetes or some container orchestration? Okay, a few of you already. If you don't use that, it doesn't even matter. That's just my demo here. But I created this test. Let's go back to the end-to-end test that verified my system locally, right, against localhost here. But now, if you use this test lifecycle, what I just did, that means an end-to-end test that just connects against the system. Then you can reuse the same test, not only locally, but against an environment that runs somewhere. So for example, I have a Kubernetes cluster, not on my, let's stop the whole thing here, not on my laptop, but in the cloud. I use the managed Kubernetes service. And then I have something like kube control. So if you know Kubernetes, then you probably know this. For example, to get the services and the deployed applications and whatnot. So this is Kubernetes stuff, but it doesn't really matter. Where I can just deploy something, system test, against my cluster that runs. So I have a cluster that's deployed on the managed Kubernetes IBM cloud that I use, and then ultimately I can use this to create, that looks familiar, to create applications for a barista, for a coffee shop, for the database, and so on and so forth. And that now runs on my cluster in the public cloud, right? So I can use, once that is up and running, I can go and connect against this thing. It gives me my public IP address and say something like coffee shop, resources, orders. And once that is being deployed and up and running, it says, oh, great, hello, 200, okay, and here are your coffee orders, right? Looks familiar. Basically, I just deployed my application on my production or test, in this case, system test environment in a Kubernetes cluster. Okay, for most of you, that's boring, whatever, I just deployed it somewhere else, doesn't matter. But now the interesting thing is, first of all, this container orchestration enables me to deploy, services with a different implementation when it makes sense. For example, the system test environment creates this barista. If you've seen Kubernetes, you know a lot of YAML, right? Doesn't matter, don't care about the YAML, care about this line. It does not create the actual barista, it again creates the Docker image or a container for the wire mock. So in this system test environment, just as before, I actually don't have my barista, I have a mock. So I can use the same scenario here that actually runs on a system test like environment. And in Kubernetes, I can even swap some instances against mocks. And then I can use the same environment that I had before. Where is it? My system test, and we now run it from the command line. And then run it against, I now just reconfigured this, what you saw in the code. I can run this now against my other environment, create order test, which runs right now, against my Kubernetes cluster. So what I want to say is, if you build up your tests by crafting reusable components, you can then use the same tests, even use the same code, and just configure it against another system. And you don't have to recreate all of this efforts all over again. You just use the existing code, the existing knowledge of how to create the test scenarios, and fire it against something else. And then you can, I just created all of my coffee orders here on the cloud, whatever. And that works, and I even use this wiremock service, right? The same thing works if I go against an actual end-to-end test without the wiremock, with the actual barista. I can use the same test code, then just fire it against another system. The only problem is then I end up with 20 actual coffees, right? Because then it's the actual barista system. But you know how I can reuse these things, and this helps a lot. So this is the example that just uses the same code, coffee order system. Here I reconfigured this against the other URL by using the same code, same JUnit test. Also, again, runs fast, and just use this. And now as the last thing, I again say this mostly to developers. I care a lot about this, test code quality and crafting these proper abstraction layers much more than I care about which test framework to use. If you have some Java knowledge, then you probably would expect some, fancy test frameworks like, I don't know, Spock testing or Scala test or whatnot. There are many frameworks that make writing all of these tests where I just used boring plain JUnit a little bit easier. But ultimately, this, just plain JUnit, nothing else. But ultimately, it's much more important to care about these test code qualities and crafting proper abstraction layers. Because ultimately, if you don't do this, and if you don't end up with maintainable tests in this way, then the best test framework, will not help you. If you change something on the production code, and then all of your 100 fancy test classes then fail, and you have to throw them away as well, right? Another thing that I want to show you is, from a tester's perspective, is one counter example that I like. Because it helped a few times. This is, you probably know, is Cucumber with gherkin syntax. Who knows this? Hands up. Okay, well, that's, wow, many more people than usual. Why do I like this syntax and this way of BDD, behavior-driven development, and many talks and resources how to properly explain this. But for me, it's basically creating a human-readable description of what you should test and then implementing this somewhere, right? So as a test QA person, you might come up with these fancy sentences, and then that is implemented somewhere. It helped sometimes in projects, from my experience, to communicate between testers and more technical developers or other engineers to say, okay, this is the actual test scenarios, this is what we should verify. When you create a valid order from espresso from Colombia, then it's valid, right? And otherwise, if you create an espresso from Germany, Germany doesn't have coffee, then it should be rejected, things like that. And then it will be implemented, in another abstraction, something like step definition of how to run my cucumber test, and then you come up with a cryptical explanation, how that is implemented. But now, if you look at it from an engineering perspective, you see the same things before. I also use reusable components to say create coffee order, get order, and so on and so forth, assert that it matches, same story again, right? So depends whether this makes sense. From my experience, to sometimes help whether you have especially some domain experts who are less technical, who then can communicate on a more human-based language. So this works with such examples, or it also works with a parameterized example, and so on and so forth. But then it already, from my perspective, this is more like programming already, right? And you can also write this in Java. And I also have a counter example where I was in projects where we had some domain experts and non-technical people who were totally fine with reading and writing this code, right? Because imagine if you don't have any Java knowledge, or maybe you actually don't have any Java knowledge, you read this code just as a reasonable human being. New order, espresso Colombia, blah, 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 system, create order, right? So if you think about it, okay, it will probably create an order with espresso from Colombia, right? Even if you have no clue about Java, then you probably wonder, okay, why there is such a such a bracket, and why this is the strange semicolon. But if you just ignore it and say, okay, create order espresso Colombia, then you probably understand what this is about, right? And I had this in projects that people were totally fine by reading this, if you come up with readable test code in the first place, right? And this is where it helps you, because then if you think about it, this is actually not that different to what I write here, right? The only thing why I really like this Gherkin syntax is it forces you to stay on this abstraction layer and to craft human readable stuff, and then how to implement it. But again, if you care about proper code quality and abstractions and delegation, you come up with such a technology in the first place, and come up with such a Java code, and then it's readable as well. So in my experience, that is probably the most important thing to take into consideration. And that is also a question where I say, and this is maybe a nice closing statement, where then testers and developers, engineers should work together, because ultimately, it goes back to very similar, even working modes or constructions where we say we should care about that the stuff we create delivers value to our users, right? That's the ultimate goal. And for that, we have to work together to basically say, as a developer, well, we should, from a developer's perspective, we should create something that delivers value, right? And as a developer, I say, I actually cannot understand coders who say, oh, I don't want to test, or, this is boring. I say, no, actually, I do want to test, because I want to be sure that whatever I do actually works later on, right? And if I come up with such, concerns where it's just really maintainable and where it's fast and where it's even fun to create this, then it's just so much faster and more efficient, right? Because ultimately what happens, if I create crappy code, then in the worst place, it ends up in production, and then there will be a bug from a user, or slightly better, it will be some QA person will find it, and then it will come back to me anyway, and I have to fix it anyway. And that's just so much more inefficient because of that slow feedback loop. So ideally, we work together, and then you come up with test scenarios that are crafted much better, with that experience from the testers, but that you as a developer can also reuse it and use it while you're coding. And then ultimately you end up with a scenario that is much more maintainable, much more effective, and much more fun to use. I hope that was helpful. Spasibo большое, and thank you very much for your attention.